Okay, so I'm going to solve these slowly now with a full commentary. This is actually the third time I'm doing the test, so hopefully I get it right this time. So this car is going around this curve in a circle, and so on every problem you must do this. You have to put in the free body diagram equals the mass times acceleration. So in this case, we know that's going to be m times v squared over rho, because that's the only acceleration. It's traveling in a circle. It's a normal tangent from the top view. So from the top view, what you're seeing is there's that car. It's going at 216 miles per hour. And so there's the acceleration, v squared over rho. And it is not accelerating out of the page, or we're not given that information. Okay, so that's the mass times acceleration. So the free body diagram, and so I noticed when I was walking around, many of you were having trouble with this. The weight always goes down towards the earth, and so that's 3,600 pounds. And by definition, the force perpendicular to the ground, so it's on the 33-degree incline, is called the normal force. And perpendicular to that, there's a friction force, which I'm going to assume going up. Actually, the friction force is coming down, but that, it says it's about to slide, so it's going to be mu times n. Okay, so we have to use this to solve for the unknowns. We're given the velocity and the radius, so the two unknowns happen to be mu and n. Okay, now we just need to put in the numbers. Okay, the mass is 3,600 pounds divided by gravity. The weight divided by gravity is the mass, and so in pounds, the gravity in feet per second squared is 32.2. And 3,600 over 32.2 is actually slugs. Okay, the velocity is 216 miles per hour. We're going to have to change that to feet per second, so I'll leave that blank. And the radius was 1,000 feet. And so the velocity is 216 miles per hour. And to convert this, we have to change the miles into feet. So it's 5,280 feet. Let me double check that. A lap around the track is 440 yards. 4 laps is a mile. 3 feet per yard. Yeah, 5,280 feet per mile. So see how that's 1. 5,280 feet equals 1 mile. So we're just multiplying by 1. And we need to change the hours into seconds. And so, 60 seconds per minute, 60 minutes per hour. So 3,600 seconds per hour. Okay, so, that's how this works. That will cancel that. That will cancel that. And so, feet per second, it becomes 216 times 5,280 divided by 3,600, 316.8 feet per second. Okay, so I'm going to just put that back in up here for the feet per second. Okay, and I'm going to just multiply that all out. So, 16.8. Let's square that, divided by 1,000, divided by 32.2, and multiplied by 3,600. That's 11,220 pounds. Okay, so the natural coordinate system, if we're trying to solve for n and mu n, would be to take normal and tangent. So we're not going to, we need to get n so that after we solve for mu n, we can solve for mu. So I'm going to just go ahead and get n first. And so I'm just going to call these directions, so not to get confused with this normal and that tangent, I'm actually going to call these x and y. Okay, so I'm going to go in the x direction first, so sum fx equals max. So we're going to have to take some components. That's 33 degrees. And that is 33 degrees. Okay, so just taking along the x direction, this direction here. Okay, we're going to get, oops, let's do the y direction first. I'm sorry. Y direction first. Oh, you know what? We'll just do x first, since I already wrote it down. Mu n minus 3600 sine 33 degrees. That's everything on the left-hand side of the free body diagram. Equals, in the x direction, this m v squared over rho is 1100 2020 pounds. So 11 to 20 cos 33 degrees. And so we'll go ahead and solve for mu n. Mu n equals, so I just noticed I made a sign error. Let me fix this right here. The x component of the m times v squared over rho is pointing down to the left, so that should be a minus sign right here. Okay, so solving for mu n, we get minus 7,449 pounds. So it's actually going down, not up. And that makes sense. The car's going so fast, it's trying to slide up the track. So it's kind of funny. I've been going slow now, and I get it wrong. And then I just checked, and I did it at full speed. I got it right. So let's continue. Sum Fy equals MAY. So now we're going to do everything in the y direction, up to the left. So we get n minus 3600 cos 33 degrees equals, and this time it's 11,200 going up and to the left, so that is positive sine 33 degrees. And so the normal force is 9,130 pounds. And so mu is just mu n divided by n, which is 7449 over 9130, which is there we go, 0.816, no units. And I found a solution for this, so I did get that right, and I also got it right when I was doing the problem at full speed.